in that way you can use. And suppose you want it to be fixed again, you can use fix. So this is how you can use fix and float option. We'll not go further into it. So next, then I'm going to take another component. I'm taking a bare input shaft. Now I'm going to rotate 90 degrees. I'm going to put it in this direction and click. So use concentric mate. Okay, so you can use that option also. Now I'm just going to use coincident mate. Okay, let's click select this face and select this face. So there is a default coincident option. So assembly in SolidWorks is very intuitive and very easy to understand. So you have selected two faces here. So according to two faces, coincident command has come. So if you want to learn more about SolidWorks assembly and mates, you can go to my other course, which is SolidWorks basic tutorial introduction course. That is my first course. You can visit that, and I will leave a link below to that course also. So all the detailed topics of our assemblies have been dealt with there. So basics only I've been teaching here in this course. So coincident mate has been applied. Now suppose you want to change the distance. So what you can do is, there are two methods. You can go into this mates tab, you can change the concentric mate, but for now I'm going to leave it that. Now you can go to coincident mate, and suppose I want to have some 5 centimeters, so I can do that. And if I want to change to 2 centimeters, I can do that. Click OK. Okay, so in this way you can do. Or one more method is there. Suppose 10 mates have been created for 10 parts. Suppose I don't know which mate is connecting with which part here. Suppose I don't know which the mate is working with this part. In that case, I can go and click on this part and right click here, click on view mates. Then automatically whatever mates are associated with that part, it will appear. Okay, this is very easy to understand when there are 10 to 15 mates or 20 more than that. So you'll be confused of which mate is with which part of the body. So in that case, it's very easy. So go ahead, edit feature, we can use it in that way also. I suggest to practice this one, because it will work when you're working with large assemblies. So in that case, it will be very useful. Okay, let's move further. Now I'm going to bring another part, or you can simply, first I'll show another part. One more shaft I'm going to give. Okay, then click again, change the angle. So this is in X direction, rotate component about X, and rotate component of Y, and rotate component of Z. So I'm going to rotate about Y. Click here. Okay, then click mate, concentric, then shaft, face, and this face. Okay, the same thing. I want 2 mm. You can give that. It's not going outside. So what thing you can do is give somewhat smaller value. So I'm still going 0.5. Okay, no problem. We'll adjust with that. The shaft is very small. Suppose in case I want to edit this material or this material, suppose I want to make the length of the shaft much bigger than this one. So what I can do is, I can go to edit feature. In SolidWorks you can edit the parts in the assembly mode itself, but for the thing you need to save. See, okay, just I click there. Now go again to the mate, I'll give coincident here. Okay, click that face and click here. Okay, select the value whatever distance you want, 5 centimeter, and give 7.5. okay, whatever distance you want you can give. Click OK. So in this simple method you can create very fastly the gears. Okay, now what I need to do is go to display relations. Actually it's overdefined, I think. So just go to delete all. So what happens is there is no relations between them. So click on these two, just give 150. And I will do one thing. I have given a relation between these two, so that come 100. Okay, now we'll give 110. This is not a standard gate box, so none of these dimensions are of standards. Okay, so you can do that. Now you can see these two are not aligned with each other, so you can do that also, not a problem. Go to edit part. This is the cut extrude one. Okay, I'll go here. I'll do the same thing. Just you need to remember the value which are given, 110. Again, it is coming as different dimension. So 110. So you can see now it has come to the position. Now I am going to give a third gear, hopefully a bigger dimension. I am going to give 50. Still not meshing, so I'll give to you 55. Will try. 55 will be a bit much, so 53 or 54. Just we are learning how to create gear assembly, so the gear teeth and the speed ratios, all this doesn't matter. You can try an example from your textbook or not if you're studying, or you can try a standard gearbox, but just for the sake of the tutorial we are giving a random gears, how to do gear assembly and how to get simulations and results. Okay, for that purpose we are not giving any standard gears. Okay, we'll try, I think this will work, so let it be 53. No, you are not able to see how to mesh the gear, so what I will do is I'll give a plane here. Okay, I'll just drag it. Okay, simply what I will do is I will use change transparency, so in this way I can see it, or simply I'll hide it. You can do both of these things. Okay, now you're able to see the parts clearly. Now what I'll do is actually it will come out of the gear if you try. That's way. So what you can do is it will not perfectly work with each other. So one thing you can do is you can go inside, zoom in, and try to make it touch with each other. Okay, and if it is interfering also, no problem, the gear will rotate. Okay, so these are, keep in mind that these are not standard gears. I think it's a bit small, not accurate results will come. So what we'll do is we'll get a bigger one. We'll select 54 or 53 depending. Now 54 will try first. Yeah, it is appropriate, I think. Yeah, it's more than good enough. Now just try to touch it. Okay, suppose you want to check whether it is interfering or not, you can check with interference detection, but for this tutorial if it is interfering also, no problem, but in real life it's not interfere with each other, otherwise gear friction will come to play. Okay, even it is in 0.11 mm also, it will damage the gear in long run, so better be careful, but for our purpose we are not worried about the interference and all. Now suppose you can see that if I'm trying to rotate this one, it's going outside and inside, because coincident is not being detected here. Now what I'm going to do is I'm going to give coincident with respect to each other. Okay, at the same time I can going to give the 3. So I'm going to give standard smart mate. Okay, click on this one. Multiple mate mode means you can give mates to more than one part at the same time. What I'm going to do here is, so what I'm going to do is, now I'm going to select a base mate, so which will act as a reference. So I'm going to give this as a reference and select this and this. Okay, you can see the 3 mates have been coincident with respect to each other. Now I'm going to mate with this one, with this one. Okay, to give the dimensions it had already. Now, okay, we are happy with that. Now if you rotate, it's not connecting with each other. So what I'm going to do is, for that is, you're going to have a mate called gear mate. So it comes under mechanical mates. There are 3 mates here: standard, advanced and mechanical mates. So now I'm going to give gear mate here. Listen carefully. So here I'm going to click on it. You will see a gear ratio. Okay, actually you need to have standard gear ratio for standard gearboxes, but for this tutorial we are not using any standard. I'm saying it again. So I'm going to be shaft. Select the shaft. Better to select shaft. You can select anywhere, but if you select the shaft, it will give a automatic teeth diameter. So this is not accurate. Now remember that this is 26, I think 25 or 26 something. So if you don't remember, no problem. You can go here and check what is the teeth. Okay, that is 35 actually. So again, go to mate, go to mechanical mate, go to gear mate, use the shaft, select the second shaft. So I'm going to hide it. Okay, now I'm going to give it's in centimeters, so it will be 0.2, 2.5, I think 3.5. Okay, you can change the units later. Now what is the second one? 45. Okay, it will be 4.5. Now if you want in mm, you just go to here, millimeter. You can check whether you are given correct or not. 35 and 45. Okay, now there's one more thing called direction there. You can change that also. So it is going in reverse. Now I don't want reverse, I want straight only. You can give reverse also. You can see, as you can see, it is working. Now I'm going to give for this mate also. I'm going to connect these two gears. Okay, now go to mate, gear mate, gear. Now I'm going to give this gear with this gear. Okay, now it will be 45 to, which is this one, it is 54. Again, no reverse. Okay, now again we can give mates to shafts also, from shaft to gear, and gear to gear, again gear to shaft, again shaft to gear. So in this way, shaft, pinion and gear you can give simultaneously, but for this video we are not doing that. You can do that, try that example also. Okay, now we'll see, try a demo whether it's working or not. You can see it is perfectly working. Now I'm going to go to motion study. So this is what somewhat different here, very easy to understand. There are 3 modes here: animation, basic and motion analysis. Again, this motion study basic also I have explained in my previous tutorials. So now for now I'm going to just brief you. Animation is nothing for you to make videos so that you can show any GIF videos, or any, suppose you are working for a office, you can show product videos. You can do that using animation. Basic motion is nothing but, as the name indicates, basic motion means, suppose you're giving a rotation, translation, or different kind of basic motions. So all those motions can be given, which are basic in nature. And third one is the most important and used one, that is related to analysis. That is similar to simulation only, but it is for a moving part. Okay, so that is called motion analysis, analysis of a moving body, simply put. Okay, now there are 2 things we need to keep in mind. First we need to give is motor. Okay, motor is nothing but as you know what the function of motor is to provide power. Okay, it converts electrical energy into mechanical energy. That's what we are going to do. So here we are going to give power to the gear. Okay, now it's had two motors here, linear and rotatory. Since that is a rotating one, it will be rotating. So you can give linear motors also, it will move translational. Okay, now automatically it will select motor location and as well as direction as well. Suppose I want to flip the direction, you can do that. And with respect to relative, means relative to this shaft also you can give, no problem if you don't give also. Okay, now I'm going to give constant speed. Okay, RPM. Generally gears work in RPM, gear and gearboxes. Okay, in different units also you can give. Okay, now I'm going to give 960 RPM. Click on it. Okay, you can see a time frame has been formed. It is going for 5 seconds. Now if you see, if you want to calculate or give a motion analysis, click on this one. As you can see, it is working perfectly. Now suppose I want to see the output. This is the input, now I want output. Okay, now what I need to do is I bring this back, I give it in transparent mode. Now what I will do is I will give a simulation to that. Okay, here you can see simulation only available for motion analysis only. You can see for this two it will not be available. Okay, now I'm going to give what is, I'm going to apply a force. Why? Because gears have loads, so this shaft has some load whatever, and but since we have not connected these two, I'm going to give a load on this one. Okay, I can give torque, but because in turning body you can give force also, but generally torque is applied. I'm going to give 100 Newton meter mm, sorry, uh, for that. And if you want, I can give for this one also. I want result for this, that's why I want to give force torque to this one also. I will make it half, it will be 50. Okay, and this way I can give, and it will work in the opposite direction of the, sorry, relative direction. I will change that to opposite. Now you can see these two torques have not been applied by because in basic motion. So I'm going to give 50 in opposite direction. Actually the gear is rotating in clockwise direction and I have given the torque in anti-clockwise direction. Okay, now you do that, we'll go to simulation setup, click on that and select whichever body you want to give result. Okay, select this one and select 5 seconds. Okay, the more times you select, the more time will take to analyze. Okay, the lesser time to take to reset. So it is directly proportional. To take 10 seconds, it will take longer compared to 5 seconds. Okay, since I given for 5 seconds, I am given 5 seconds here also. So it's asking us to assign a material. Okay, yes, I have not given any material in assignment, so we're going to select plain carbon steel for all those things. Okay, you can see motion simulation has been set up. Now I'm going to run this simulation. Okay, this is pre-processing. Okay, now click on this one. It is asking us to simulate. It's saying that current motion study is out of date. Means since changing the torque and all we have added, so it is asking, it is outdated, so it's asking us to say run. You can say yes. So it is running again and it will process. It will take some time. Okay, it is generating a mesh. Now it is going to analyze. Okay, fairly fast process, because this value is very small. We'll try 100. I think yeah, as you can see, if I set the frames much bigger, much bigger time will take. So if you want a fast result, you can give smaller frames, or you can set the time limits very small. But what will happen is it will not able to calculate accuracy. So the better the accuracy, if you want, you need to give lot of time, and it depends upon computer to computer also, the processing speed, graphic card, all those things work. Okay, now we are going to get result. Before going to simulate this one, I'm going to apply contact also. Why? Because these three gears are in contact with each other. So I'm going to give a contact also. What will happen if you don't give contact is these three will rotate with respect to each other, but there is no friction, or this kind of contact forces will not be supplied to each other. Okay, so the simulation will be not realistic. So you need to give contact. Okay, there are two options here: solid bodies, curves are for materials which have no solids, or you can give curves that select as the edges also. And the solid bodies is for gates which are solid. Okay, you can use contact groups. Suppose you have 10 components, so one is having 5 groups, and other one is having another 5 components in one group. So in this way, group to group you can give contact. So what will happen is, if you give group 1, if you give group 2, so whatever components are there in group 1, they will, even if they are touching each other in group 1, they will ignore the contact. They will only work on contacts which are between two groups, not in between them groups. Okay, suppose group 1 is there and group 2 is there. So in 5 gears, if even if the, suppose you take this shaft and gear, suppose these two are touching with each other, suppose these two are in the same group, the contact will not work, means the simulation may not take account of the touching of this. But if these two are there, suppose this one is in group 1 and this one is in group 2, the contact will be taken account for these two. Again same for this thing, shaft and pinion, as these are in the same group, the contact between them will not be applied. So that's how group works. Now we are not going to see that group. Okay, now I'm going to select these three, click OK. Now just simulate them, click yes. So it will try to do a motion analysis for me. Now you can see, I am just telling you, I'm going to fast forward this video, as will take a lot of time. Okay, I will skip to the end part. So the meshing results has been completed. So we are going to select first here one more stress. So we are going to see, here you can see the plot. Okay, this results are for the third gear. Similarly, you can simulate for these two gears also. So the value is maximum 6.5 and 10 power 4 in Newton meters, and the lowest value is 7. Okay, similarly we can give deformation also, how much the element has deformed. So it is 2.55, that is in 10 power minus 1, that is nothing but 0.25. So very small deformation. So this gears will